So we are starting the topic called probabilities. Okay. So let's see from the beginning what is all about probabilities. Fine. Okay. Let's go
Okay,
ahead.
sir.
Yeah. Yeah. So what is probability? Probability means chance. Okay. Yeah.
Yeah, sir.
Probability means chance. So the chapter is today probabilities. Probability means chance. Okay. It is nothing but it shows happening or non-happening of an event. An event, if you are performing an experiment, if you are tossing a coin, if you are seeing for falling of head, okay, there can be a chance that head can fall or a tail can fall. So anything is possible. So we are studying regarding all these things right now in this chapter regarding the possibilities. Okay, possibilities, probability or chance, all are same. Now let us start with some basics here. Random variable. So yesterday I discussed and told you what is a random variable. So see the picture here. So see here, you are tossing a coin. We could get heads or tails. It is understood fact. So let's give them the values 0 and 1. We are giving, it can take any value. Okay. The We can give any value to the outcome. So outcome is nothing but either head or tail, and we are giving two values to it, 0 and 1. So the random event is nothing but tossing a coin. So I tossed a coin, I got 0. 0 means heads. I tossed a coin, I got tail, 1. Okay. So here x is the random variable. So what does it show? X is a random variable which can take any value, either 0 or 1, when you toss a coin. That means when a random event happens, so the event's outcome is nothing but whatever it is. So we are giving numbering to it. That is random number. Okay. So now let's go for the random variables and see a very good example regarding this. So what does the textbook say about the random variables? So random variable is an uncertain quantity or number. We don't know what that number would be. It can be anything. So if head falls, if I say 0, if tail falls, if I say 1, so whatever falls, that is not certain. It is uncertain. So whatever falls, that is taking a number. Okay, that number is random variable. Okay. So if tail falls, we are terming as 1. That is a number it is taking. If head falls, we are terming it as a 0. That is the number it is taking. So it can take any number. Okay. So an outcome is a possible result. Okay. Let us see. An outcome is what? A possible result. An event is the specific outcome. Okay. See, simple probability. So what is an outcome? Outcome is nothing but a possible result. If you toss a coin, the outcome can be head or tail. An event is a specific outcome. That means your tossing of coin is an event. Okay. A favorable event is nothing but what the outcome which you are looking for comes. Okay. So a favorable event is the outcome you are looking for. And random means all outcomes are equally likely to occur or happen. Okay. So random means anything can happen in that. Whatever outcomes are available, any of them can occur. And the occurrence of those outcomes are equally likely. That means there is a chance, there is a 50% chance of, if I toss a coin, the probability of getting a head is 1 by 2, the probability of getting a tail is 1 by 2. That means 50% chance that head can fall, and 50% chance that tail can fall. So that
Tail
is
can. Yeah.
equally likely, that any one of them can occur. Okay. Random, very good, synonym for random is fair. That means if it is a fair like experiment, anything can happen. If it is a what we say, it is a fixed experiment, then whatever you want, that would come. So random means fair. So the probability that an event will happen is a number between 0 and 1. Okay. So a probability of 0 means the event will definitely not happen. Probability of 1 means that event will happen. All other probabilities are between 0 and 1. So Impossible 0, definite 1. So 50-50 chances 1 by 2. So probability that an event will happen can also be described as a percent. Impossible things we don't think it may happen. 100% means definite, that you're always concerned that this will happen, and either that can happen or it may not happen, that is 50-50%. So let us see some other kind of example for distributions. Now, so we have discussed all these things. A random variable is an uncertain quantity or number. Outcome is an observed value of a random variable. An event is a single outcome or set of outcomes. Mutually exclusive events is nothing but happening of one will prevent the happening of another. Exhaustive event is nothing but all the possible outcomes. Okay. So let's see a dice. So the number that comes up is a random variable. If you throw a die, if 4 comes, that's a random variable. If you throw a die, if 6 comes, that's a random variable. Okay. What is a probability distribution? Now let's see an example for a probability distribution. Okay. So here you can see probability of the spinner stopping. Okay, fine. This is not required actually. We have already done probability. I'm just explaining you the distributions. Just a second. I have a very good slide. Yesterday we were going with that example. Yeah, this one. So here we are going with the probability distributions. Okay. So what is a probability distribution? A variable is defined as characteristic or attribute that can assume different values. Okay. Yes, a variable can take any value. Okay. Because it is a variable. That means it can vary. It can vary. That means it can take any values. Okay. So a variable whose values are determined by chance is called random variable. Yes, that means if you are tossing a coin and if head falls, that falls because of some probability. What is the probability of you getting a head when a coin is tossed? 50% or 1 by 2. So can I say the falling of head, if I say falling of head is 1, so the probability of getting that 1 is 1 by 2. Yes, that 1 you are getting because of some chance or some probability. So can I say that one which you got when you toss the coin, which is nothing but which denotes head, is a random variable? Yes. So what I mean to say here, so there is a coin, you're tossing a coin. So probability of tossing a coin is 1 by 2. And suppose head falls. So probability of getting a head is 1 by 2. If I am saying head as 1, so the probability of getting 1 when a coin is tossed is 1 by 2. And this 1 is out of this probability, because there is a if you want to get this 1, there should be a probability of getting this, because you are performing an experiment. So you performed an experiment and you got 1. The probability of getting that 1 was 1 by 2. That is, probability of getting a head is nothing but 1 by 2. Sum of the like number of favorable cases divided by total number of cases. Okay. So number of favorable cases is 1, which is what you want, divided by total number of cases is 2, which is 2. So here you can see, now if a variable can assume only a specific number of values, such as the outcomes for the roll of a die or the outcomes for the toss of a coin, then the variable is called a discrete variable. So discrete variables are nothing but countable ones. So like if a variable can assume only a specific number of values. For example, if you toss a coin, okay, so there are only two cases here, 1/2, that is getting a head, and 1/2 getting a tail. That's it. So for example, if I speak about discrete distribution, see if I write like this, these are all countable ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is a distribution? Distribution is nothing but whatever the probability you have. You are just showing that probability like this. That means you are showing, you are like, this is nothing but distribution. So distribution is nothing but division. Okay. So whatever the probabilities you have, if you perform any experiment, those probabilities are distributed in this way, or those are shown in this way, in this form of representation. Okay, if this is the way they are shown, that is discrete distribution. If this is the way they are shown, that is continuous distribution. Okay, that is normal distribution with continuous attribute or continuous characteristics. Now next point. So a variable can assume only a specific number of values, such as the outcomes for roll of a die or the outcomes for the toss of a coin. Then the variable is called discrete variable. That means it is taking some specific value. It's a discrete variable. Okay. Now if I say something like this, so this is like, suppose rain falls, and if I put some like parameter to this, that is -3 to +3 centimeters. It can take, suppose it is -2, -1, 0, 1, 2. Suppose if I say the rain is falling, if it is like you go to a hospital and see the pulse rating, it will be like this. It will be going on. It can take any values between two parameters. Am I right? So if I say the rain is falling and the estimation of the rain is between 2 and 3 centimeters. So the rain can be anything between this, like 2.1 centimeters, 2.11 centimeters, 2.111 centimeters, 2.112, 2.113, 2.2489, 2.4568, anything. It can take any values between these two parameters. So can I say that is continuous distribution? Yes, because discrete is countable. It cannot take any values except what I'm saying here. Okay, the probabilities of outcomes, whatever you are showing here as a representation, cannot take any other values. See, if I say like, suppose this is the this is the probability. Probability is this, and this is the like outcomes. Okay. So these are the outcomes, these are the probabilities. So your outcomes, whatever I'm showing, okay, if it is in this way, this is discrete because these are countables. Okay. Now suppose you toss two coins. Okay, I'm taking this as like this. So what is the sample space if you toss two coins? There are two coins here. Coin number 1, coin number 2. So it can have two heads, yes. Two tails, yes. One head, one tail, yes. One tail, one head, yes. So these are the four possible outcomes. So the sample space is head head, tail tail, tail head, tail tail. This is sample space. Okay. Now if I ask you a question, so they have made a tree diagram. Actually they have gone in this way, head and tail. Okay. So again head, tail, head, tail. So when two coins are tossed, okay, it is head head, head tail, okay, tail head, tail tail. So head head, which I said, head tail, and tail head, and tail tail. Okay, these are the four outcomes. Now, so from the tree diagram, this is the sample space we got. So if X is a random variable, so here your outcome, whatever you are seeing are these outcomes. Okay, two heads, two tails, one tail, one head, and one head, one tail. So if x is a random variable for the number of heads, then x assumes the value 0, 1, 2. How? Let us see. So here the number of heads is 0. So what we are doing, we are like, we want something out of it. So we are specific about the number of heads. So what we are saying is, let us give some number to the outcomes of heads from this particular experiment. Let us give numbers to the outcomes from this particular experiment of tossing two coins. So if I want to see how many heads are there, I have to definitely give them numbers, and those numbers which I give to these outcomes, that means where I'm specific that I want to see how many heads have fallen, that is nothing but a random variable. Okay, yes. So here two heads, one head and one tail and one head, and two tails. Here there is no head, here there is one head and two heads. So let us see here what is happening. In this case 0 heads, in this case one head, in this case one head, in this case two heads. So can I say the random variables are nothing but 0, 1, 2? Yes. So whatever the outcomes here I am seeing, and out of those outcomes I am specific that I want to see the number of heads, and I want to give numbers to those number of heads whatever have fallen. So the numbers which I give to those heads is nothing but the random variable. So let's draw them in a diagram. So those random variables, what I'm seeing here, the number of heads, these number of heads have a probability to occur. So what is the probability? So the probability of no heads occurring is 1 out of 4. How? See, see, there is no head here. So this particular here I can say there is no head. So the probability of no head is 1 by 4. How? 1 out of this 4 cases. Okay, 1 out of this 4 cases. So that is 1 by 4. The probability of only one head is here one time, here one time. It is 2 out of 4, and the probability of getting two heads is 1 out of 4. So probability of getting no head is 1 out of 4. Probability of getting one head is 2 times, that is 2 out of 4. That is 1 by 4 plus 1 by 4 you can write. Probability of getting two heads is 1 by 4. Now, let us put these probabilities along with their outcomes in the distribution. So a probability distribution consists of the values of random variable. So what are the values of random variable here? 0, 1 and 2. These are the values of the random variables. So what is a probability distribution? Very clearly the definition along with the explanation is given. A probability distribution consists of the values of a random variable which is 0, 1, 2 that can assume and variable can assume, and the corresponding probabilities of those values. That means probability distribution is nothing but whatever the outcomes I've got, I will distribute them as per their probabilities. Okay. Now, so here the probabilities are. So I have taken the probabilities. See, the probabilities are very clear. 1 by 4 is 0.25. This is like 1 by 2, 0.5, and this is 0.25. Okay. So 0.25, 0.51, and here the number of hits. So these are the outcomes. Those are the random variables, and these are the probabilities. So the probabilities that these have occurred is given in this way. So I am just plotting them, and this is a distribution. Okay. So let's see what is a distribution. A probability distribution consists of the values of random variable which are 0, 1, 2 in this case, and can assume and the corresponding probabilities of the values. So probability distribution consists of the values of a random variable can assume and the corresponding probabilities of the values. That means we are distributing those random variables as per their probabilities. That is probability distribution. Distribution of random variables or the outcomes as per their probabilities is probability distribution. So the probability that no heads occur is 0.25. We can see here we have plotted. The probability of getting two heads is one head is like 1 by 2, that is 0.5, and the probability of getting two heads is 0.25, that is this. So this is a discrete probability distribution because it is countable. Okay. Now, till here everything is all right if I'm not wrong. So here one more example, like probability of getting 1, 2, 3, 4, 5, 6 when a die is thrown is always 1 by 6, 1 by 6, 1 by 6, 1 by 6. Okay, that's enough. Leave it. Now we'll go for the textbook. Now, so probability distribution describes the probabilities of all the possible outcomes for a random variable. So here the probability distribution what has described what the probabilities of all the outcomes or all the random variables. So describes the probabilities of all the possible outcomes of random variable. So we have the random variable in this way 0, 1, 2. So probability distribution describes the probability of all the probabilities of outcome of the all random variables. Probabilities of what? Outcomes of all the random variables. So probability distribution describes probability of all possible outcomes for a random variable. So here the possible outcome of this random variable is 0.25. Here the possibility of random variable of this is 0.50. Here the possibility of the random variable occurring is again 0.25, or probability of this occurring is this occurring is this occurring is this. So this is the probability distribution. So probability distribution is nothing but it shows the probabilities of occurrence of all this possible outcomes of random variables. Next point. Now discrete random variable I have explained you what is that, and probability function. So you know probability function is nothing but probability, this is the probability function, or probability of x is equal to r. So probability function specifies the probability that random variable is equal to specific value. Okay, no worries, this is okay. Now let us see this question. Evaluating a probability function. So consider the following function x 1, 2, 3, 4. Probability of x is x by 10. Okay. Else probability x is 0. So now you put all the this one like whatever are there in this function and put into this and find their probabilities. So this is the function x1 x is equal to 1, 2, 3, 4. This is the probability of that function. So probability of that function would be nothing but in place of x you have to put all this. So you have put, and the probability you have got the combined probability, that is nothing but the sum of the probabilities, that is 1. Okay, so everyone should know this fact that sum of the probabilities is always equal to 1. That means probability of success plus probability of failure is always equal to 1. Next point. So I have explained you regarding the continuous random variable. Okay, so discrete or countable. Continuous is it can take any value. See 1.99999992 point. So it can take any values. Distribution functions, probability density function and cumulative distributive functions. These are the two functions. Let us see about them. Just a second. Just a second. Just give it into this. Just a second. Just give it into this. Just a second. I'm again starting this. Okay. Now, so we are starting with distribution functions. Okay. So you should know about distributions. We will cover up this chapter in details afterwards also. There is a chapter specifically called distributions. But right now we are concerned with the distribution functions. Okay. So let us see here. So this is the probability. Here there is a cumulative distribution function and probability density function. So cumulative distributive function. This is a part of probability distribution. And PDF, probability density function. Okay, or probability distribution function. So I have shown the probability distribution already to you what that is. Okay. So now if f of x is a function, for example, probability x less than equal to x. Okay. Since probability, this is the probability. Okay. Probability. So let us make a graph and understand this. What it is actually. So I will show you with the help of an experiment here. Okay. I'll show you with the help of an experiment these two things. So you listen properly what is happening. So in an experiment, a trial consists of 3 successful tosses of coin. Okay. In an experiment, example. In an experiment, a trial consists of 3 successive tosses of coin. If we define an random variable, so you know what is random variable, we already discussed the basics. X, so we are taking x as the number of heads appearing in a trial, determine probability of x and f of x. Okay. So probability density function. So we are supposed to find what here? So PDF and CDF. Okay. So cumulative distributive function and probability density function or probability distribution function. Just a second. Now let us go ahead. Now, so the CDF is what and probability density function is what. Okay. So now let's go ahead. Like x is a random variable, for example, and here I am taking 0. You are tossing 3 coins. So let us see the outcomes. Tails, heads, okay, and and it can take, next one is what actually, okay, we'll go in this way. So here no heads, okay, then head, tail, 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 head, tail, and tail, tail, head, okay, and here head, head, tail, and head, tail, head, and tail, head, head, okay, and here again heads. So here the probability of not getting even a single head is 0. We have already done such kind of things with 2 coins, so I'm taking 0. And this is 1, 2, 3, 4, 5, 6, 7, 8. 8 outcomes. So what's the probability of getting no heads? It is 1 by 8. Okay. So I'm taking probability of x is equal to x, that is 1 by 8. So I'm writing the random variables and their probabilities, and I'm going to show them in a probability distribution. But that's going to be different in this case and this case. That's the shape is the only difference there, because cumulative means it takes the previous value also into picture like this. It will go in this way. Okay, I'll show you. Don't worry. Now, 1, 3 by 8. So here there are how many heads? 1, 2, 3. So probability of getting 2 heads. So probability of getting 1 head is 3 by 8. 2 heads is 1, 2, 3. 3 by 8. These are the random variables. And the probability of getting 3 heads is again 1 by 8. Now, so now what we'll do, the sum is always equal to 1, sum of the probabilities. Now we are doing cumulative. So cumulative is nothing but 1 by 8. 1 by 8 plus 3 by 8 is 4 by 8. 4 by 8 plus 3 by 8 is 7 by 8. 7 by 8 plus 1 by 8 is 8 by 8, that is 1. Okay. Now see the graph. That's the only difference. We have already done the graph regarding this. Only we are showing this now. That's it. वो तो आपको पता ही है, ये बता रहा हूं मैं. So see, we are writing the probabilities on the y-axis. I would have done the theorem also, but with theorem you will be unnecessarily getting confused. So it is better for you to show in this way with the help of an experiment example. Probability always on y-axis, outcomes on, that is random variables. So this is a distribution. Why? Because we are showing the random variables along with their probabilities here. How the random variables are distributed based upon their probabilities, we are showing here. So random variables distributed based upon the probabilities. So 0, 1, 2, 3. Okay, this is the zone distribution. Like each area is taken by each random variable, and here it is like 1 by 8 and 4 by 8 and 7 by 8 and 1, that is 8 by 8. Okay, so here it is taking this. So can I can write this like this. Okay, now for 2 it is taking what is the probability of getting 2 heads? 4 by 8. 4 by 8, yeah. So it's going till here. So it is like you are adding 3 by 8 to it. Okay. Now, so this was till here, it was 1 by 8. Here it was 1 by 8. Then 1 by 8 plus 3 by 8 is altogether what? 4 by 8. And what is this? 7 by 8 and 1. So again till here we will take. Okay. So here again 1 by 8, 3 by 8, 4 by 8. 4 by 8 again here I can write 3 by 8. Yes. Again last and final step. Just like I am writing what? 1 by 8, 3 by 8, 3 by 8, So 1 by 8 again here. So this is the cumulative distribution function. So what is happening? The next one, this one 4 by 8 is including this or not? Yes. 7 by 8. So here it is 4 by 8. Na? This 4 by 8 is including 1 by 8 or not? Yes. Next one, 7 by 8 is including 4 by 8 and 1 by 8 or not? Yes. 8 by 8 is including all of them or not? Yes. So I'll show you that here. Just a minute. So here f of 1. So here I can write in such a way, in 1 probability of 0 is contained. 1 has the probability of 0 or not? Yes. Okay. That is 1 and 0. In 2, the other probabilities will be there. So I'll be writing that. So I'll show you that as a function. Please listen. So f of 1, if I want this f of 1 is equal to probability of 0 plus probability of 1. What is the probability of 0? No heads, 1 by 8. What is the probability of 1? Getting 1 head is 3 by 8. So that is 4 by 8. Okay. So exactly for 1, are you getting 4 by 8 or not? Yes. Now f of 2, that has the probability of 0 including all, 1 plus probability of 2. 1 by 8 plus 3 by 8 plus 3 by 8, 7 by 8. F of 3, that is 1, the total. Okay, again 1 by 8 you'll add to 7 by 8. This is the CDF. Let's go ahead. We'll do the probability density function or probability distribution function. So probability distribution function is very normal. The one which we already have done. The one which we have already done in the first example, that which I told you, that is discrete, it's countable. So same thing I'll continue. Yes. So here is the probability, here is the random variable. So I'll put it 0. These are the only probabilities. 0. Or you can put it like only one line, no problem. ऐसे एक line put कर दो. Or else you can put it like this also. Anything is all right. Okay. Probability density function or probability distributive function. Now, one thing you should understand. Here you are clubbing everything. That means this shows the integration actually. Okay. I'll write it here. Here these all are divided. You can see these are countables. So I'll write some properties. Relationship between probability density function and cumulative density function. So f of x, this is capital. Sorry, capital F of x. Small f of x. Okay. So you know, like one thing. Just a second. Just a second. Okay. So cumulative distribution function is capital F of x, and this one is small f of x. So this is, you can see, cumulative distributive function is f of x, probability of x less than equal to x. That means all of them are before this. Okay, this is the total. So it is probability of x less than x. F of x is nothing but probability of less than equal to. Now for PDF it is small f of x. Okay, now this one. So now here you can understand some relationships. D by dx of cumulative difference distributive function is PDF. So cumulative is always like this. It is taking all of them. It is clubbing. It is clubbing in the sense integrating. If you want to break this integration, you have to differentiate. And in the same way, integral of probability density function is cumulative distributive function. Okay, like that. So d by dx of capital f of x is small f of x. And integral of small f of x is capital F of x. Now, okay. So this was all about the distribution functions. We are done with this. Next, we'll go for the next topic. So see, cumulative is always in this way. Why? Because it is always increasing. Have you seen the same thing here in our graph? Yes, see here. It is always in this way, see. This way. It is in this way. Okay? Because it grows, it starts from the lower point and it always accumulates the previous probabilities and it goes up like this. But again, it will be in this way. Why? Because at one point it has to become 1, the total. Okay. Now probability density function is this. This is like a normal probability density function which we have seen here. So you can see here the probability density function. It's like this. It's like this. Am I right? I'm not, see, it can be continuous or it can be discrete also. It is not necessary that it should always be discrete like this. ऐसा जरूरी नहीं है कि हमेशा डिस्क्रीट रहना है, कंटिन्यूअस भी रह सकता है. प्रोबेबिलिटी डेंसिटी फंक्शन कुछ भी रह सकता है. ठीक है, वी हैव ऑलरेडी सीन द डिस्क्रीट वंस एंड द कंटिन्यूअस वंस आल्सो. कंटिन्यूअस का एग्जांपल क्या लिया? रेन का ड्रॉपलेट्स 2.1 सेंटीमीटर, 2.11. डिस्क्रीट काउंटेबल्स. So we will do this last question and wind up. And tomorrow I can finish the chapter. So discrete uniform distribution. So let us see here. Probability of 6, f of 6. This is CDF. This is PDF. X lies between 2 and 8 for the discrete uniform distribution function. So x is 2, 4, 6, 8, 10 and probability of x is 0.2. So we are taking the probabilities here and we are taking different like random variables. Okay. So multiply this. So you'll get this like, no, not multiplying. Just add up this one. You'll get the cumulative distribution function. So 0.20, 0.20 plus 0.20, 0.40, 0.40 plus this 0.6, 0.6 plus this 0.80. So we are writing all these probabilities here. Okay. And we are just framing the graph. So we started from 0.20, it is 2. So 2 is taking 0.20. 4 is taking 0.40 here. It is clubbing these two probabilities. And 6 is taking 0.60 here. And 8 is taking 0.80. Okay. And the last one is still 1. Okay. That is understood fact. 10. This is CDF. Okay. So please go through these questions and this topic and we will do the next concepts tomorrow. Tomorrow we will do the conditional probabilities. If I am not wrong, already in my Bayesian analysis or Bayes theorem, I have already explained regarding this. So tomorrow will be a brush up kind of this brush up kind of thing for this. and tomorrow will be the end of the probability chapter at any cost. Then we can start distributions in this. Okay, because we have done the basics of distributions very properly, that will be also very easy for you, and it will be finished in a short span of time, most probably 2 days. Okay.
Awesome.
Yeah, see you tomorrow. Bye bye.
Bye.
Bye Chandra.